So, continuing on in Unit 4, Chapter 3, and again, maintaining the quantities. Don't worry, we will be coming back to those chemical reactions here very, very shortly. So, empirical formulas are, again, it's based from usually a percent composition. This is just kind of the first step in doing a longer process. The examples that we tend to do, or at least in most general chemistries, empirical formulas are there. We touch on it because it shows us application of what we've learned. It runs us through this process. You're usually given a percentage of the elements, okay? We go under the impression that it's 100 grams. Why? Because you can only have 100%. If we have that, because everything has to be accounted for, and everything has a percent attached to it, and we just say, well, if it adds up to 100%, go with 100 grams. Okay? Just make that, infer that. Then you have that. You use a molar mass, which we use our periodic tables for, to convert to moles. Once we have it in moles, we need to be able to determine the lowest possible number. From there, you just do some division, which then tells us the empirical formula that we need. This is, again, the lowest possible. Does not always tell us the actual formula. Okay? Other information that a person could do in the laboratory would give us more information, such as functional groups, things such as that. Organic spectroscopy, for those of you that have to do it, will be what you could do further and beyond. So, let's try it out. The compound para-aminobenzoic acid, usually listed on a bottle of sunscreen as PABA, is composed of carbon, hydrogen, nitrogen, and oxygen. What is the empirical formula for PABA? Now, one of the things that a person would be like, well, I could just Google it. Yeah, you can Google it, but that's not going to give you the empirical formula. And a lot of times in general chemistry and high school chemistries, we have you use compounds that you should already know, or you're going to come in contact with known compounds. So we have, again, we're going to go under the impression that it all adds up to 100%, and therefore, when I come in through and say, let's go, carbon is going to be 61.31 grams. Hydrogen is going to be, it's probably going to be a little too close, so we'll erase that, give myself some space here. Hydrogen is going to be 5.14 grams. Nitrogen is going to be 10.21 grams. And oxygen is going to be 23.33 grams. Remembering that percentage equals amount in grams. So amount in percent is the amount in grams. Okay, so that's where I got those numbers from. Now we need to have our periodic table. To find the molar mass of carbon, which is 12.01 per mole. I like to set a lot of mine up. Doesn't matter if I set them all up or do the math right away. Not really. I could do the math right away. I think it does. Honestly, it doesn't matter. It will come down to what do you feel comfortable with, and what allows you to get the correct answer the majority of the time. On whether or not you... Oh, that should be a 1. Looks like a 7 there. You have to do what you feel comfortable with. Now, one of the benefits of this is that once you kind of start doing these, you'll find, man, converting from grams to moles, it's always like doing the same thing. Yes, it is like doing the same thing because it is doing the same thing over and over and over again. Some of you will find, and this is where, again, a lot of the practice comes in. Just punching some of these numbers in on my handy-dandy calculator. Since I don't have these values memorized, if you do, you are a better person than me. Make sure I have those there. And oxygen. All right. So I'm going to write out the elements that I have, because I know I'm going to have at least one of them, right? So I can write them out. And now I'm just going to go and find which one of these numbers is the smallest. The nitrogen one, the 0.73, right? Well, 0.73 divided by 0.73 is going to give me 1, right? Do that in a different color here. Gives me that 1. Now I need to divide all of them by 0.73 because that's my ratio. And I was just guessing on the 1.46, but it's pretty darn close to 2. Now these other ones I'm going to have to, it's a little bit tougher of a guess. Again, going to use my handy dandy calculator. My ACT approved handy dandy calculator. Because it's good to know how to use your ACT approved handy dandy calculator. And I get this 6.98, and you're like, okay, could I round that just up to 6.9? Yeah, but why don't you just round it up to a whole number? Since we can't have 0.9 of an element or 0.8 of an element, we just round them up. And both of these are going to round up to 7. So the empirical formula for para-aminobenzoic acid is C7H7NO2. Let's try another one out, but a little bit different. Mesotylene, a hydrocarbon found in crude oil, has an empirical formula of C3H4. The molar mass is determined to be 121 grams per mole. What is the molecular formula? So this one's a little bit different. This one we have a molar mass, meaning the full molar mass. They must have put it through like a NMR to determine the molar mass. They have an empirical formula of C3H4. Now we have to find some other things from it. I'm going to resize this up to give myself some room. So, the molar mass, we know that, okay? But here's the thing. And this is the kind of what makes this one the trick into this one. The molar mass that was determined of the 121, is that of the empirical formula mass? There's one way to verify that. And that would be looking at doing a formula mass. So let's do a formula mass to see if that 121 is. Okay? Because here's the thing, remember, our default setting needs to become, when in doubt, convert to moles. Well, I can only convert to moles if I have some more molar masses. Well, I know what my numbers are. Some of these students eventually start to memorize. They become a little scared. They're like, oh my gosh, how do I know that already? Oh my gosh, Peterson's in my brain. It's scary. Nope, assimilation is going to happen. Resistance is futile. So I end up getting a molecular mass, or molar mass, of 40.07 for the empirical formula. The molar mass is 121 grams, which means there's a certain ratio. Now, here becomes the next question is, do I divide 40.07 by 121? Well, that would give me a small number, wouldn't it? Well, I wouldn't want to do that. I already have, this is already the smallest that it can be. I need to ramp things up. So, if I take 121 and divide it by 40.07. Gotta roughly get a value of somewhere around 3 something. A ratio of 3. Which means that I need to increase everything by 3. By a factor of 3. So my empirical formula is C3H4. My molecular formula, 3 times 3 is 9. And 3 times 4 is 12.